Okay, so hi everybody. So today we're going to go ahead and do the sample question number 1 from the BC 2020 release test question, I guess. Okay, so we'll just jump right into it. Okay, so you have this graph here, and it says the continuous function f is defined on the closed interval from -6 to 5. The figure above shows a portion of the graph of f consisting of 2 line segments and a quarter circle. So that's a quarter circle. Centered the point 5,3. It is known that the point 3, 3 minus the square root of 5 is on the graph of f. Okay? So if f is equal to, if the integral from -6 to 5 of f of x dx equal to 7, find the value of -6 to -2 of f of x dx. Show the work that leads to your answer, okay? So notice here we're going all the way from -6 to 5, and this is only from -6 to 2. So we can break this apart into different pieces, okay? So I'm going to come to this other side so you can see this a little bit better, okay? So you have the integral from -6 to 5 of f of x dx is equal to the integral from -6 to 2, -2, because that's what's given, of f of x dx plus the integral from -2 to 5 of f of x dx. Okay, just simply breaking it apart. Oops, sorry. Okay, so just breaking it apart in 2 pieces. Okay, and I know that this is 7. So if 7 is equal to the integral, this is what I'm looking for, -6 to -2 of f of x dx. Now, what is the integral from -2 to 5? So go back to the picture. So this is what f of x is. So I'm going to go from -2 to 5. So all I have to do is use the area under the curve to go ahead and get there. So here's the thing, though, as you notice, if you're going from left to right, this is going to be a positive value, and that's going to be a negative value, and you can see that those are the same area, so they're going to cancel each other out, and it's going to be 0 there. Okay, similarly here, this is going to be a negative value, and that's going to be a positive value, so those will cancel each other out. So as I integrate from -2 to 1, that is all going to go away. It's all going to be 0. So all I'm left with then is figuring out what the area is of this region right here. Okay, I'm going to break it into 3 distinct regions, okay? So I have this region right here. That's easy. That's just a length. That's just a rectangle or square of area 1. Here you have this triangle, which is 2 by 1. So 2 times 1 divided by 2 is going to be 1 as well. And then I just have to figure out what this area is. The problem is I have no idea what that formula would be to figure that out. But I do know that this is a quarter of a circle, right? So if I trap this with a square, this square's area is 9. But I don't want all the area. I want to take away this portion of it. Well, that is a quarter of a circle with the radius 3, okay, because that'd be the center. So I'm going to go 9 minus a quarter of a circle, so pi times r, but r is 3 squared, all over 4. 4 because it's a quarter of a circle. And so this gives me 9 minus 9 pi all over 4, which is 36 over 4 minus 9 pi all over 4, which gives me 27 over 4. So that's what the area of this region is. So going from there all the way to there, it's 2 plus that. Okay, so this would be plus, or I'm missing a pi here, right? Wait, I can't combine those. What am I doing? That doesn't have a pi to it. I can't combine those. Okay, so I'll just leave it like that. I'm sorry. I wasn't even thinking. Okay, so I'm going to go ahead and leave it like that right there. And then, so this is going to be plus 9 minus 9 pi all over 4. Okay? And now we just need to solve for this. So subtract all this over. So subtract the 9 to add that. So if you subtract the 9, you're going to end up with -2 plus 9 pi all over 4 is equal to the integral from -6 to -2 of f of x dx. Okay, and you can leave your answer just like that. Okay, B. Evaluate this integral. So in 3 to 5 of 2 f prime of x plus 4 dx. Okay, so B, I'm going to integrate from 3 to 5 of 2 f prime of x plus 4 dx. Well, that's equal to, factor out the 2, so 3 to 5 of f prime of x dx plus the integral from 3 to 5 of 4 dx. Sorry. Okay, so then just continue working on this. So here I'm integrating the derivative. Now, it'd be easy if I had the equation for the derivative, but I don't. I only have a graph for f. So I need to go from the derivative to the function f, so I just know I need to integrate. Oh, well, lucky me, that's what I'm doing. This right here is the first fundamental theorem of calculus. So this is going to be equal to 2 times f of 5 minus f of 3. That's what all this is. And then plus the integral of 4 is just 4x. So 4x, and this is still, and this is evaluated from 3 to 5. So this is 2 times f of 5. So go to the graph. F of 5 is 0. So that's 0. Minus f of 3. F of 3 is right here. I don't know what that point is, but I do know it is because it gives it to me right there. It's 3 minus the square root of 5. So this would be minus 3 minus the square root of 5. And then plus, so you're going to have 20 minus 12, which gives you 8. Okay, so just distributing that in there. I'm going to have, let's see, 2 minus a negative 3. Sorry, 2 minus 3, so that's negative 1. Oh, I'm sorry, I'm distributing this. So 2 times a negative 3, that gives me negative 6. And then 2 times a positive, because the negative times the negative is a positive. So 2 times that gives me plus 2 times the square root of 5, and then plus 8. So this is equal to 2 plus 2 root 5. Okay, so there we are. Okay, moving on, part C, okay? The function g is given by this equation. Find the absolute maximum value of g on the interval from negative 2 to 5. Okay, so absolute maximum value. Okay, so the key here is I need to know what is going on with g prime, right? So g prime here, if you notice, g prime of x is equal to f of x by the second fundamental theorem of calculus, right? There's ft dt. So by the second fundamental theorem of calculus, I know g prime of x is equal to f of x. Okay, so I need to know where it's its absolute maximum. So I need to know where the derivative goes from increasing to decreasing. So the derivative goes from positive to negative. So all I need to know is where does f of x go from positive to negative at? So if you look here, where does it go from positive to negative? Well, this is f of x. It goes from positive to negative right there. So I should check and figure out what g of negative 1 is equal to. I should figure that out. Okay, and then here it's negative, 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 positive. So right here it switches from a negative value to a positive value, but I don't care about that because that means it goes from decreasing to increasing, which means it's a relative minimum value. Okay, and then we continue along as we go here, and so positive, 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 0. So I really just need to go and check what g of 5 is equal to. Now, there's one more point I need to check, and the key here is that it says absolute maximum. If it's absolute maximum, you have to check the endpoints, so we have to figure out what g of negative 2 is. Okay, so g of negative 2. Okay, so I'm going to go to the other page. I'm going to go to write these out. Okay, so I have g of negative 2. We'll start there. By the definition is equal to the integral from negative 2 to negative 2 of f of t dt. Well, you know that's equal to 0. Anytime you integrate from one point to the same point, you get 0. Okay, then we're going to do g of 5. Well, g of 5 is from negative 2 to 2 of f of t dt, sorry, negative 2 to 5, which is equal to, so I kind of have to go back and redo what I did before. But if you notice, where am I at? Do I actually know what that is? Negative 2 to 5. Yeah, I did it somewhere. Where did I do it? Oh, here it is. Negative 2 to 5, right here. Negative 2 to 5 was equal to this. So this is going to be 9 minus 9 pi all over 4. Okay, and we should probably try and come up with an idea of what that's going to be. Okay, and then I have to do g of negative 1. So g of negative 1 is going to be the integral from negative 2 to negative 1 of f of t dt, which is equal to, so negative 2 to negative 1, oh, that's just a half. Okay, the area of that is just a half. So this is equal to a half. Okay, so absolute maximum value, you just have to determine what is going to be the absolute maximum. Is it going to be here or is it going to be here? This is bigger than a half, so g of 5 is what our absolute maximum is going to be, which is 9 minus 9 pi all over 4. Okay, so there we are. Okay, and then D, the last one, we just have to evaluate this limit. Sorry. So the last one is for D, I need to go ahead and figure out, okay, well, what is the limit then as x goes to 1 of 10 to the power of x minus 3 f prime of x all over f of x minus arc tan of x. Okay, well, we know basically the only thing you have to do is just plug it in. You do have to make sure that there's nothing weird that's going on at those spots, so we can go back and check that in a second. Okay, so the first one is 10 to the x, so that's just going to be 10 to the power of 1 minus 3 times the derivative of f of x. Okay, now this is the derivative, this is f of x, and at 2, because I'm plugging in 1, at 1, the slope of the tangent line is 2. So this would be times 2 all over f of 1. F of 1 is 1, right? And then minus arc tangent of 1. Where's arc tangent equal to 1 at? It's equal to 1 at pi all over 4. Okay? And this is your answer. You can just leave it as is. Okay? There's no reason to simplify it from there. Okay? E. Okay, so E, it says, the function f has derivatives of all orders and all real numbers x. The proportion of the graph of f is shown above. Along with the line tangent to the graph of f of x at x equals 0, selected derivatives of f at x equals 0 are given in the table above. Write down the third degree Taylor polynomial for f about x is equal to 0. That just means it's Maclaurin. Okay, so E, what you're going to do is, Maclaurin, or Taylor centered around 0, is going to be f prime, the zeroth derivative evaluated at 0, x to the power of 0 over 0 factorial, plus the first derivative evaluated at 0, x to the first all over 1 factorial, plus the second derivative evaluated at 0, x squared all over 2 factorial, plus the third derivative evaluated at 0, x cubed all over 3 factorial. But I know I don't need to go any higher than that, because I'm only asking for a third degree Taylor polynomial. So I just need to evaluate this. Okay, so what is the zeroth derivative evaluated at 0? So how are you going to figure out what that is? Well, that's just the original function evaluated at 0. And the original function, which is this curve evaluated at 0, is 3. Okay, so this would be 3. That's 1. That's 1. So just leave it alone. Okay, plus the first derivative evaluated at 0. So that's going to be the slope of the tangent line evaluated at 0. Well, that's already given to us. And you can see this has a slope of down 2 over 1. So that's negative 2. So f prime of 0 is negative 2. So I have minus 2 times x all over 1 plus the second derivative evaluated at 0. Now this is where they give it to us in the table. The second derivative evaluated at 0 is 3. So this is plus 3x squared all over 2. And plus the third derivative evaluated at 0. The third derivative evaluated at 0 is there, negative 23 halves. So minus 23 halves x cubed all over 6. So cleaning this up, you have 3 minus 2x plus 3 halves x squared minus 23 twelfths x cubed. Okay, and that's what the third degree Taylor polynomial expansion for that is. Okay. F, let h be the function defined by this. Use the Taylor polynomial found in part E, so the thing we found up there, to find approximation for h of 1. So what is h of 1? So F, we're going to have h of x is equal to the integral from 0 to x of f of t dt. But what do we know the approximation for f of t is? It's right here. So this is the integral from 0 to x of 3 minus 2t plus 3 halves t squared minus 23 over 12 t cubed dt. Okay, integrating this, so I have h of x is equal to 3t minus t squared plus 1/2 t cubed minus 23 all over 48 x to the fourth, and this is going to be evaluated from 0 to x. So this should be a t here. Okay, so then right, so then we plug in x. So I have h of x is equal to 3x minus x squared plus 1/2 x cubed minus 23 48 x to the fourth. And then when you plug in 0, you can see it all goes away. Now I want to figure out what h of 1 is. H of 1 is going to be 3 minus 1 plus 1/2 minus 23 48. And I'm just going to leave my answer as that because in calculus and the AP exam, you do not need to reduce these. Okay? Okay, and then G. G says evaluate the integral from 1 to infinity of 1 all over x to the p plus 1 power dx. Well, that is just equal to the integral from 1 to infinity of x to the negative p minus 1 dx power, which is equal to, raise it by a power of 1, so I have x to the negative p all over negative p. And I'm going from 1 to infinity. Now, I just realized that I did this wrong because I was getting in my mind, I was kind of thinking multiple choice. But remember what we have to do here is you can't write it like this. You have to write it as a limit. This is the limit as a goes to infinity. And so there should be an a right there. Okay, so there's going to be an a right here, and you have the limit as a goes to infinity. So this is equal to the limit as a goes to infinity of, so I'm going to go ahead and clean this up. So I have negative 1 all over x to the power of p, and then you have p on the bottom here, and I'm evaluating this from 1 to a. So this is equal to the limit as a goes to infinity of negative 1 all over p, and you plug in an a for x. So you have p a to the power of p minus a negative, so plus 1 all over, and you're plugging in 1 now, so it's p times x. Oh, but I'm sorry, I plugged in 1 for the wrong value. This is 1 to the power of p. Okay, so what is the limit as a goes to infinity of a to the power of p? Well, that goes to infinity. So this whole entire thing is going to go to infinity. Negative 1 over infinity is 0. So that goes to 0. So that's equal to, so that goes away. And then over here, well, there is no a. So this is 1 to the power of p is just 1. So this is just 1 over p. Okay, and there we are. Okay, so hopefully you don't have any questions with that. If you do, please feel free to contact me. Okay, take care.